Good morning, friends. I, Dr. Devis Bandil, Associate Professor, Swiss Gyan Vihar University, that is accredited by NAC A grade. Today, I will discuss about the Radix Sort. Now, I am sharing my PPT. I hope you can see my PPT. About the Radix Sort, I will discuss about Radix Sort today in this lecture. Your Radix Sort is the one of the technique of your sorting algorithm. Before discussion about the Radix sort, I would like to discuss about the course object and outcome of this paper, that is your data structure and algorithm. You know, the object of data structure and algorithm is that to emphasize the concept of your algorithm, to emphasize the concept of your sorting algorithm, to emphasize the concept of your stack, to emphasize the concept of your linked list, to emphasize the concept of your queue. And after studying this lecture, student will able to how to write the algorithm, how to find the complexity of your algorithm, how to apply the concept of your stack, how to apply the concept of your queue, how to apply the concept of your linked list, searching and your sorting. And as per I had told, I will discuss about the Radix sort. So Radix sort is the one of the sorting technique of your sorting. If we will discuss about the sorting, so your sorting when you will arrange the all items in your sequentially fashion, that is your sorting. Suppose if you are having a array and in your array there are so many elements and your all elements are not in a sorting fashion. So that's why you can't say your array elements are in a sorting fashion. Through this technique, through the Radix sort, you can arrange the all items in your sorting fashion. Okay, and there are so many algorithms of your sorting, like your Radix sort, like your merge sort, like your insertion sort, like your selection sort, like your merge sort. And from this technique, your Radix sort is the one of the most sorting technique. That's why today I am discussing about the Radix sort. And you know, in my past lecture, I had already discussed about selection sort, insertion sort, merge sort, quick sort, and today my main focus on your Radix sort. Through the Radix sort, how you will arrange the all items in your sorting fashion. That is, now I will discuss about the Radix sort. And during this lecture, I will cover so many topics like your course object and out sorry the object and outcome of this lecture, what is Radix sort in your data structures, examples of your Radix sort, algorithm of your Radix sort, and also I will discuss about the implementation of your Radix sort. And after that, I will discuss about the advantage of your Radix sort, disadvantage of your Radix sort, and you know end of this lecture also I will discuss about the some questions which are related from this lecture. And now I will start from the object and outcome of this lecture. You know, your object of this lecture is that try to concept the Radix sort, that is your sorting algorithm. And if we will discuss about the outcome of this lecture, so after studying this lecture, student will able to how to apply this technique, and through this technique, how you will arrange the all items in your sorting fashion. That is the course out. That is the outcome of this lecture. And now, first, I will discuss about what is Radix sort. Regarding your Radix sort, I had already told that is the sorting technique. You know, there are so many techniques of your sorting, like selection sort, insertion sort, merge sort, Radix sort, and quick sort. And here I am discussing about the Radix sort. You know, Radix sort is a small method that many people intuitively use when alphabetizing a large list of items, names. Especially the list of names is your first sorted according to the first letter of each name. That is the main key point of your Radix sort algorithm. The list of names is the first record according to the first letter of each name. Suppose if you are having multiple names like your Devesh, Ram, Kamal, Mohan, Shyam, Anita, Sunita, Radhika, there are so many. You are having the so many names. Okay, the through the Radix sort, first of all, the list of names is first sorted according to the first letter of each name. Like your, suppose as per I had told, there are so many names. You are taking like your Ram, Mohan, Shyam, Kamal, Anita, Sunita. So first of all, you will take the all words as your first letter, like your Deves. The D is your first letter, Ram, R is your first letter, Kamal is your first letter. And that's why I had told the list of names is a first sorted according to the first letter of each name. That is, the names are arranged in 26 classes. Here I had told about that the names are arranged in your 26 classes because in your there are 26 alphabets. That's why I had told that is the names are arranged in your 26 classes. Okay. First of all, suppose you have to arrange as per your first letter, that is your A. After that, you have to arrange as per your second letter is your B. After that, you have to arrange as per your C, D, E, F, G. Means total 26 classes. Okay. And intuitively one might want to sort numbers on their most significant digit. However, Radix sort to work counterintuitively by sorting on the least significant digit first. On the first pass, all the numbers are sorted on the least significant digit and combined in the array. Then on the second pass, the entire names are sorted again on the second least significant digit and combined in your sorting fashion. The main key point, the main key focus of your Radix sort, you will first of all you will arrange the as per your least significant digit. Okay. And in your second pass, the entire numbers are sorted again on the second least significant digit. After that, your entire numbers are sorted again in your third significant digit, and after that you will combine in an array and so on. So that is the fundamental concept of your Radix sort. And when you want to apply this technique, always you will follow this technique as per I had told. First of all, you will arrange as per your first least significant digit. After that, you will arrange in your second significant digit. After that, you will arrange in your third significant digit, and so on. And after that, you will combine and so on. And now I will discuss about the algorithm of your Radix sort. You know, algorithm is the most important concept when you are implementing any technique. If you will not write the algorithm, and without algorithm, if you will write the program, obviously you will face the problem. Because through the algorithm, your all concepts are clear, your all instructions are clear. Okay, first of all, you will execute this step, after that you will execute this step, after that you will execute this step, after that you will execute this step. That's why the definition of your algorithm is a just write the instructions step by step. Means if you will write the instructions step by step, that is your algorithm. As per the rule, there is no any foundation that if you will write the algorithm, so first you will write this instruction, after that you will write this instruction, after that you will write this instruction. There is no any foundation. Only your step, just you will write the all instructions step by step. For example, suppose you want to make a tea, and when you are preparing a tea, so first of all you will put the water for boiling on your at your gas, and after that, after boil the water, you will put the tea. After that, you will put the milk. After that, you will put the sugar, and finally your tea have to be prepared. So that's why if you will write the algorithm for this purpose, so only your step you will write in instructions only. So that is your algorithm. Okay. And if you will write the algorithm in your Radix sort, so you will take the two parameter. First is your list and second is your n. Shift, first of all, you will take shift equal 1. After that, your loop will start from 1 to key size. Okay, suppose your key size is your 10, so your loop will start from 1 to 10. Okay, and do for entry 1 to n, do, and bucket number equal list entry dot key divided by shift more 10, and your append bucket number. And in your last instruction, in your next instruction, you will write list entry equal to combined bucket shift equal to shift multiply 10. And you know when you will analysis when you will analyze this algorithm, your each key is logged at once for each digit. On letter, if the key are alphabetic, on the longest key. Hence, if the longest key has m digits and there are n key, the Radix sort has order m dot n. That is the Radix sort order m dot n. However, if the look at these two values, the size of the key will be relatively small when compared to the number of key. For example, if we have six digit key, we could have a million different records. Here we see that the size of the key is not significant, and this algorithm is of linear complexity n. This is the analysis of your Radix sort algorithm. And now I am taking the example of your Radix sort. First of means I will take a array in which your all items are not in your sorting fashion, and through the Radix sort technique, you will arrange the all items which are already inserted in your array in your sequential fashion. In your sequential fashion means in your ascending order. Okay, like your first of all your minimum digit you will put, after that you will maximum digit put, after that you will more than maximum digit put, and you will follow this order. So here I am taking an example, and in this example I had taken a array in which your all items which are already inserted are not in your sorting fashion. And through this Radix sort technique, you will arrange the all items in your sorting fashion. And here I am taking an array in which your all items are 329, 457, 657, 839, 436, 720, and your 355. These are the all items which I had already taken, and your all items these are not in your sorting fashion. So as per I had told in your first pass, you will write as per your least most significant digit like your, and you will start from your right side. Okay, so in your right side means in your third digit, your most is your least significant digit is your zero, and the number which are concerned from your zero, that is your 720. So first of all you will put the 720 number, and after that in your input digits, your next least significant digit is your 5. That's why you will take the number is your 35. And after that, your next least significant digit is your 6. That's why you will put the number is your 436. After that, you will put the next number is your 457, because your 7 is your least significant digit after your 6, and after that you will write 657, after that you will write 329, and after that you will write 839. Means in your first pass you will write the all numbers, and in which your all numbers your last digit is a least significant digit as per your 720, 355, 436, 457, 657, 329, and your 839. And after that first pass, you will apply in your second pass. In your second pass, your in your second digit, that is your least significant digit, is your 2. That's why you have taken the number is your 720, and after that you will taken the number 329, and after that you will taken the number 436. 839, 400, 355, 457, and 657. In this slide, you can see in your first pass, your number is 720, 355, 436, 457, 656, 329, and your 839. So means in this first pass, your last digit in your ascending order. You can see here 720, 355, 436, 457, 657, 329, 839. Means your last digit in your first pass, 0 is less than from 5, 5 is less than from your 6, 6 is less than from your 7, 7 is less than from your 9, and your next number is your 9. And in the same manner, you will see in your second pass, in your second number, your all second number are in your ascending order, like your 2, 2, 3, 3, 5, 5, 5. And after that, in your third pass, you will take in your first digit, and you will put in your sequentially. Means you will find the least significant digit, that is your 329, after that 355, after that 436, after that 457, after that 657, after that 720, and after that 839. And you can see in the third pass your all numbers are in your sequential fashion. Your all whole numbers are in your sequentially fashion. You know, your 329 is less than in your 355, your 355 is less than your 436, your 436 is less than 4, and from your 457, 457 is less than from your 757, 657 is less than from your 720, and 720 is less than from your 839. Means totally you will take the three pass. Okay, and your all digits which are already inserted in your array and which are not in your sorting fashion, each number having three digits, like your 329, 457, 757, 839, 436, 720, and 355. And after the three pass, you have to got the list in which your all items are in your ascending order. You can see here in this example. Okay, and now in the above example means, as per I had taken this example. In the above example, the first column is the input. Your first column is the input means this is your first column, and this column is your input column, and here you will input the numbers 329. You have to input these numbers 457, 657, 839, 436, 720, and your 355. So the first column is the input. That is your first column, and this column is the input column. And the remaining column show the list after successive sort in a increasingly significant digits position. So you can see here in your first pass, okay, your last digits. First of all, you will take the least significant digit, that is your 0. After that you have taken 5. After that you have taken 6. After that you have taken the 7, and after that you have taken 7, and after that you have taken 9 and your 9. And the code for Radix Sort assumes that each element in an array A of n elements has d digits. Okay, where your digit 1 is the lowest order digit and the d is the higher order digit. So basically, this is the fundamental concept of your Radix sort algorithm. As per I had told, the first column is the input column. The remaining column show the list after successive sort on increasingly significant digit position. The code for Radix sort assumes that each element in an array A of n element has d digits, where digit 1 is the lowest order digit, has d is the highest order digit. So you will always follow this technique when you want to apply the Radix sort. And now this is the implementation of your Radix sort. Means here I had discussed about the Radix sort algorithm, and also I will discuss about the how to implement the Radix sort in any programming language, like your C language, like your C++ language, like your Java language. There is no any foundation. You will implement this technique only in this language, only in this language. That is depend on you. If you are comfortable in your C language, so you should implement in your C language. If you are comfort in your C++ language, so also you should implement in your C++ language. That is depend on you. But there is no any foundation key. Only you will implement this technique only this language, only this language, only this language. You can implement the technique in any language as per your comfortable. So here, you know in a C language, first of all, you will take the header file, because your all input and output functions are also declared in your header file. That's why you will take the header files. Okay, and after that you will make a function get max. Okay, in which you will take the two parameter, your int a and your int n. Okay, and your max equal to the a0 mean that is your zeroth index. And your loop will start from your 1, and I less than equal to I less than n, and your I plus plus. That is the syntax of your for loop. And I hope all are known about the for loop. First of all, you will write the declaration. After that, you will write the condition. After that, you will write the increment or decrement. So here in your for loop, your first of all you have to initialize I equal to 1. After that, your I less than n and your I plus plus. Okay, so if your ith element is greater than from your max, so your ith element will assign to your max and you will return the max. And after that, you will make a function for your Radix sort. Radix sort, you will also take the two parameter, and you will take a bucket of your dimension is your 10 by 10 suppose, and your bucket int your dimension is, and your size is your 10. And you have already taken the four variables like your I, J, K, R, and your NOP equal to the 0, and divisor by the 1, LAR pass, and LAR equal to get max, in which you will take the parameter two parameter A and your N. And after that, while largest is greater than 0, so your NOP will be incremented and your LAR modulo by 10. You know, I hope you should know about the modulo. Modulo means suppose you will follow the expression 10 divided 10 modulo 2. So that time your modulo will be your 0. Suppose your 11 modulo 2, so that time your answer will be your 1. Okay, and again your pass, first of all initial level your pass will be start from 0 and less than from your NOP, and your pass will be incremented, and in which your loop will start from 0 to 10. 0 to 10 means 0 to 9, and I plus plus, and your bucket equal to 0, and your for I equal to 0, I less than n, and your I plus plus, and your AI divided by divisor, and percent means you will find the modulo and your percentage. And after that, for k equal to 0 less than 10, your loop will start from your 0 and run till less than 10 plus plus, j equal to 0, j less than bucket, and your j plus plus. Okay, and after that, your number will be print as per your bucket. Kj will assign to your AI and your I plus plus, and multiply divisor multiply 10, and you print the after pass means that is the implementation of your Radix sort. And after that you will make a function in which first of all enter the number of items to be sorted. Suppose you want to sort the 10 items. Okay, so you will take the value of n is your 10, and after that scanf you have to input the value, and after that you will print the enter all items. When you will enter the all items, so your loop will start from your 0 and less than n, and your plus plus, and for your scanf ampersand AI means first of all your a zeroth element will be enter. After that your a1 will be element and enter. After that your second element will be enter. After that third, fourth, fifth, sixth, seven, eight, and your 9. And after inputted the all elements, you will apply the Radix sort function. And I have already made the Radix sort function in which I had taken the two parameters a and n. So first of all you will fire a message sorted items, and your loop will start for print the all items. Your loop will start from your 0 and less than n plus plus. So first of all your zeroth item will be print. After that, one item will be print. After that, second. After that, third. After that, fourth. After that, fifth. After that, sixth. And after that, your seven. Okay. And now, okay. After discussed about the Radix sort, how to apply the Radix sort, and what is Radix sort, how to write the algorithm of your Radix sort, and how to implement the Radix sort either in your C language, C++ language, Java language, PHP language, and other language. Now I will discuss about the advantage of your Radix sort, why your Radix sort is essential, and what are the merits of your Radix sort. Each sorting algorithm has a merits and your demerits. So in a same manner, your Radix sort will have a merits and also will have a demerits. And here, first of all, I am discussing about the all advantage of your Radix sort. Your first advantage of your Radix sort is that fast when the key are short. If your key are short, so your Radix sort will be fast. That is when the range of the array elements is less. Okay, mean that is your first advantage of your Radix sort. First, when the key are short, that is when the range of the array element is to be less. And the second advantage is that used to suffix array construction algorithm like your Manverse algorithm and your DC3 algorithm. So these are the two advantage of your Radix sort algorithm, of your Radix sort technique. First is that first when the key are short, that is when the range of the array element is less, and used in suffix array construction algorithm like your Manverse algorithm and your DC3 algorithm. So these are the two advantage of your Radix sort. Okay, if you are using the merge sort, if you are using the selection sort, if you are using the insertion sort, if you are using the merge sort, so your all sorting algorithms have a own advantage. In the same manner, your Radix sort will have a own advantage. As per I had told, first is your fast when the key are short, and second is your used in suffix array construction algorithm like your Manverse algorithm and your DC3 algorithm. And now, if we will talk about the disadvantage of your Radix sort, since the Radix sort depend on the digits or letters, the Radix sort is much less flexible than the other sort. You know, this is the disadvantage. Radix sort is a much less flexible than the other sort. Your other sorting algorithms like your insertion sort, like your selection sort, like your merge sort, like your quick sort. So your Radix sort is much less flexible than from your insertion sort, from selection sort, from merge sort, from your quick sort. Hence, for every different type of data, it need to be rewritten. Okay, that is the first disadvantage of your Radix sort. And your second advantage of your Radix sort is that the constraint for Radix sort is greater compared to other sorting algorithms. Again, I'm saying the constant for Radix sort is greater compared to other sorting algorithm. That is the second disadvantage of your Radix sort. And in your third, it takes more space compared to the quick sort, which is in place sorting. Okay, so this is the another disadvantage of your Radix sort. you know as per I had told, every sorting algorithms has a own disadvantage and your advantage. In the same manner, your Radix sort have the own advantage and on disadvantage. And your disadvantage, your Radix set depend on a digits or your letters. Okay, digits. Suppose your 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, and your letters suppose A to Z. Okay, and the constant for Radix sort is greater compared to the other sorting algorithms, and your it takes more space compared to quick sort, which is in place sorting. Okay, so these are the all disadvantage of your Radix sort. And in this lecture, I had discussed about the Radix sort, like what is Radix sort, and how to write the algorithm for your Radix sort, and how to implement the Radix sort in any programming language, like your C language, like your C++ language, and your any other language. Okay, and as per I had told, at end of this lecture, I will discuss about the some questions which are related from this lecture. Okay, your first question is that which of the following is the distribution sort? First is your heap sort, smooth sort, quick sort, and your LSD radix sort. So your distribution sort is the LSD radix sort. Means LSD means least significant digit. So not a heap sort, not a smooth sort, not a quick sort, or not a LSD radix sort. You know, your answer will be your LSD radix sort. That is your least significant digit radix sort. Means your answer will be your D answer. And next is that what is the worst case complexity of your least significant digit radix sort? Your first option is that your n log n, second option is that your wn, third option is that your n, and next option is your n plus w. So the worst case complexity of your least significant digit radix sort is your wn, not a and the NWN not a worst case time complexity, not a N is the worst case time complexity, not a N plus W is the worst case time complexity. Your answer will be your WN, means your WN is the worst case complexity of your LSD radix sort, means of your least significant digit sort. That's why your answer will be your A, not a answer, not a C answer, not a D answer. Your answer will be your B answer. That is your worst case time complexity of LSD radix sort is your WM. And next question is that LSD radix sort require passes to sort n elements. Okay, again I'm saying LSD means least significant digit radix sort require passes to sort n elements, like your W upon log R, your first option, and W upon log R second option, W upon log Rn is a third option, and your Wn upon log n is your fourth option. You know your LSD radix sort require W upon log R passes to the sort n elements, not a W upon log R, not a W upon log Rn, not a Wn upon log n. That's why your answer will be your A answer, that is your W upon log R. And next question is that which of the following is false? LSD radix sort is an integer sorting algorithm. Means your least significant digit radix sort is an integer sorting algorithm. And LSD radix sort is a comparison sorting algorithm. Means your least significant digit radix sort is a comparison sorting algorithm. And LSD radix sort is a distribution sort. Means your least significant digit radix sort is a distribution sort. And in your fourth, LSD radix sort uses the bucket sort. Means your least significant digit radix sort use the bucket sort. Your LSD radix sort is a comparison sorting algorithm. This statement is a wrong statement. Your LSD, your least significant radix sort is an integer sorting algorithm. That is the right statement. LSD radix sort is a distribution sort is the right statement, and the LSD radix sort uses the bucket sort. That is the right statement. That's why your answer will be your LHD Radix sort is a comparison sorting algorithm. Means your answer will be your B, because as per your question, which of the following is your false? So you know your second option, your second statement, that is your least significant digit. Radix sort is a comparison sorting algorithm. That's why your answer will be your B answer, not a answer, not C, and not a D answer. And next question is that which of the following sorting algorithm is stable? Your first is that heap sort. Your first is that your heap sort. Second is that your selection sort, and third is that your in place MSD Radix sort, and fourth is that your LSD Radix sort. So you know your sorting algorithm is stable, that is your LSD Radix sort, that is your least significant digit Radix sort. That's why your answer will be your D answer. Heap sort sorting algorithm is stable, is not stable, and your selection sort sorting algorithm is not stable, and your in place MHD Radix sort is not stable, and you know your LHD Radix sort sorting algorithm is stable. That's why your answer will be your D answer. And next question is that what is an in place sorting algorithm? Your first option is that it needs one or log n memory to create auxiliary locations. Second option is that the input is already sorted and in place. And your third option is that it require additional storage. And fourth option is that it require additional space. Okay, so you know your answer will be your A answer. Auxiliary memory is required for storing and data temporarily. That's why your first option, that is your A option, it needs one or log n memory to create auxiliary location. Not a input is already sorted and in place. Not a require additional storage in place. Not a require additional space. And you know in the following scenario, when will you use selection sort? You know the input is already sorted. A large file has to be sorted. Large value need to be sorted with small key, and small values need to be sorted with the large key. Okay, so you know your answer. Your answer will be your C answer. Large value need to be sorted with the small key. Not a the input is already sorted. Not a large file has to be sorted. Not a small value need to be sorted with large key. That's why your answer will be your large value need to be sorted with your small key. That's why your answer will be your C answer. Selection is based on key, hence a file with large value and small key can be efficiently sorted and with the selection sort. What is the advantage of selection sort over other sorting technique? It requires no additional storage space. It is scalable. It works best for the input which are already sorted. It is faster than any other sorting technique. You know your answer will be your A answer. It requires no additional storage space. That is the advantage of your selection sort over other sorting technique. You know your selection sorted, no require no additional storage space. That's why your answer will be your A. And succession sort is an in place sorting algorithm. It does not require the additional storage. What is the average case complexity of selection sort? N log n, a or n square. Your answer will be your D answer, that is your n square. In the average case, even if the input is partially sorted, selection sort behave as if the entire array is not sorted. Selection sort is intensive is as an input. That's why your answer will be your D answer. And what is the disadvantage of your selection sort? It requires auxiliary memory. It is not scalable. It can be used for a small key. It takes linear time to sort the element. Your answer will be your B answer. And the given array 1, 2, 3, 4, 5 bubble sort is implemented with a flag variable. The number is iteration in a selection sort and a bubble sort, respectively 5 and 4, 1 and 4, 0 and 4, and 4 and 1. Your answer will be your D answer. And what is the best case complexity of selection sort? Your n square is the best case complexity of your selection sort. In this lecture, I had discussed about a Radix sort technique of your sorting. I hope you have understood about this Radix sort. Thank you.